Hello, thanks for tuning in. My name's Daniel Oakey, and today we'll be going through a real-world use of Scalameta. So let's get started with the slides. So just a little bit about me before we get started. I'm a software engineer in Quantexa's core data team. In the core data team, we work with things like Kafka, Elasticsearch, and Spark. And Quantexa as a whole is actually hiring. We're based in central London with our many developers there. So if you're interested, do get in touch. We'd be really interested to hear from you. And today's talk revolves around a problem that we, the core data team, faced and how we went about solving it. So let's go and have a look at the problem. So the problem was then that we've got a lot of users with a great deal of domain knowledge, but not so much programming knowledge. So they know all about their particular domain, what their business needs. They know what the data look like, what the fields of the data are, and they know all about that, but they don't necessarily have the programming skill needed to turn that into something that they can use with our system. So if we just look at an example here. So there's a record on the screen. We've got a customer with a first name and a last name. They've got an address and they've got accounts. That's all knowledge that the customer knows about, and they need to put it into our system. Within that, there might be nested fields. And these models can become really, really complicated. And so we needed a way for these users to model their data and then get it into our system without them having to interact with, Scala. And the solution we came up with then was the idea of configuration-based models. So they would write a configuration, typically something like JSON, and then that would be turned into something that they could interact with in the system. So we've just got an example here on the screen. That's just a very, very simple bit of JSON. And the advantages then are that the user doesn't need to know Scala, and we can also abstract all of the complexity away from them. So in this example, we've got a customer, they've got customer ID, they've got a full name, and we've abstracted away the complexity of the number type, for example. So they don't need to worry about integers or longs or doubles. We can just say, here is number. And then additionally, we don't need to worry about things like nulls or options. We can just say, is the field optional or not? That's is optional, true or false. So the really great thing about this then is that we can narrow down the complex world of programming into just a small controlled interface that we can present to the user. And then we can choose how that is represented in our system. So we can output the data into Scala. We could even choose to use a different programming language. We can make adjustments and optimizations to all of that. And the user doesn't care. They can just see this really clean, sensible interface that they can drive using their config. But how do we go about getting that into our system? So the solution then is that the user writes their configuration in JSON. That is then going to be parsed into the system using a JSON parser, and then loaded as just plain data that we can manipulate. And then finally, what we're going to do is take that data and turn it into real Scala code that can then be compiled and used with the user's existing project. But first, we need to model that data then. So we've got the JSON already. We're ready to go. We've got requirements though on the JSON and on how that is modeled within our system. So a model has got a name and a list of fields. A field has got a name, a type, and also this flag indicating if the field is optional or not. And the fields type, then I think we're going to limit here to string, number, or Boolean. But it would be very easy to add other types as we wanted to increase the complexity of our system. And to represent this, we're going to just use two case classes. So case classes just being a pure data class, contains just data. Everything that the class contains is right there in the declaration. And then we're also going to have this sealed trait. So I've got model, it's a case class containing a name, the name of the model. So is it a customer? Is it an animal? Is it a business? Whatever it is. And then fields is a list of fields. Fields are named again. They've got a type. I've not used the word type TYPE because that would clash with a keyword in Scala. So just call it TPE. And then the Boolean flag there is optional. And you'll notice also I've used this sealed trait here for the field type. So what that does then is it says that field type is this interface, but all of the cases of field type are here in the file because it's a sealed trait, and they can only be this. No one else can come along and extend the code with their own version of a field type, there are only these three cases. And when we come to implement our conversion from this into Scala, we only need to handle these three cases. Everything is total on that selection of types. So that's a really good way of narrowing down the types and controlling how our code works. But how do we go then from data to code? The simple solution, and this is pretty much what I did when I started doing this problem. And my team lead said to me, actually, that's probably not the best idea. Maybe we should look at something else. Because the problem is that what we're doing is we're complecting the data with the presentation. And what I mean by that is that we're trying to do two things at once. We're trying to say, I've got this model in my memory, and I want to turn it into usable code. But at the same time that I'm converting into code, I'm also presenting, I'm also turning it into this string, okay? And generally, when we do programming, doing two things at once is bad. Because, for example, if I wanted to take my case class that I've just written out, write it out to file, and then actually I decided, oh, I wanted a different structure. I should have reformatted it, maybe put it on different lines or something. The way to do that would be then to go and reparse it, get it all over again, do all the reprocessing, and then format it, and then output it again. So what we've kind of done by doing two things at once, the data and the presentation, is we've thrown away the structure. So we really want to separate that. So that's the first really big disadvantage to this approach. And the second bigger disadvantage is that it's not syntax checked. Now, what we mean by this is that I can output some code and the compiler doesn't care how valid it is, okay? So we look at this example. I've got the convert model. It's taking my new model that we introduced before, and it's outputting strings, okay? Now, don't worry about how we're getting the fields, because that's just another implementation. But I'm using a good old string, which just allows you to put variables into strings. And what I've done is I've accidentally failed to close the parenthesis there, okay? Now, this will compile fine. But then when the user runs it on their computer, maybe weeks after we've shipped the code, there's no parenthesis, okay? And so they will get now the compile time error, that there's a syntax error, that we haven't closed the parenthesis on the case class, okay? And so what we really want to do is we want to tackle both these problems, okay? We want to produce code as data, and then have another part of the code worry about how to actually format that, present it, and then that also allows us to manipulate it as we go. And we also want to make sure that we're producing valid Scala code. And for that, we're introducing metaprogramming. So Scala programming, what do we mean then by metaprogramming? So when we think of the word meta, we might think of words like metaphysics, like meta meaning self-referential. That's kind of the top dictionary definition. So that would therefore mean that metaprogramming is programming that refers to programming. Now that's a little bit complicated, but I like to think of it as code that describes code, okay? So if we're using Scalameta, we are using Scala code to write more Scala code. So code, therefore, is data. Now that sounds quite complicated, but you have to trust me that if you look into the Scala code, of the Scala meta code, it is nothing more than more classes and traits, as we've seen before, that represent the Scala that we're writing, okay? So every definition, every method, every value, every type, all of them can just be represented as more case classes. You can just imagine writing it yourself, and indeed you could. But what do various forms in Scala look like in Scala Meta? So if we just start with this really, really simple form, it's just X, Y, Z, okay? So it's a name. It might refer to a method or a function or just a simple value, okay? And the way that we would normally evaluate this is just to look up what the name refers to, okay? And the Scala meta for this is just term.name with the name of the name inside the class, okay? So you could write this as well. You could write class name and then put like the value inside that, okay? So then we've reduced a name for something to the class that represents that. So it's now in the system as code, as data, sorry. If we just go a bit further then, so how would we represent a literal integer, for example? And the case class for this would be just an integer, so lit.int, okay? And I'll show you a little bit about how we can find out how to represent all of these things in Scala Meta in just a bit. To make it a little bit more complicated, X, Y, Z with parentheses. Okay, so that's just like if you've got a method or a function and you're calling it. And what we usually refer to this as is application. Okay, so we're applying the function x, y, z to some arguments. Okay, so that therefore we've got term.apply. So we've got a different kind of term. Okay, so you can imagine apply being one of the instances of a term and name being one of the instances of a term, and they're probably somewhere in a hierarchy in a trait somewhere. Okay, and the way this is structured then is you've got on the left hand side you've got x, y, z, the term that would be evaluated, and then on the right hand side we've got a list of empty arguments. Okay, and as you can imagine we could go further and actually put arguments into the list there. So just a final example here, we've got x, y, z is a function applied to the literal integer 42 and the literal string kitten. There we go. So as you can see then, things are built up recursively, okay? So you've got smaller parts, little terms and literals and things, and they just combine to make ever more complicated structures, but it's always the same stuff repeating recursively. So let's now have a go at playing around with the Scalameta library. And we're going to, I'll just, oh dear, how did that happen? Never mind, right. Okay, so I'm just in my project, and what we're going to do then is I'm going to go and start up SBT in a terminal. And after the conference, all of these, this project will be available on GitHub, so you can go and pull it and just play around with it yourself. And I really encourage you to do that, because I think the best way to learn is to read code and play around with code and just test things out. So we've got then a terminal, we've got SBT open, and we're going to go and start the console. And the only import you ever need when you do Scala meta is import scala.meta _. Okay, so we just import that. That'll bring in all of the types and the macros and the definitions, everything we need to interact with Scala meta. And if you remember before, we were doing classes. Okay, so we might have a class like that, and as you can see, I've not closed the parenthesis. If we do that, Scala doesn't care. Scala says, oh great, that's a string. Okay, now Scala meta introduces a number of kind of cool other strings we've got. And among those, we've got the Q string, okay? And the Q string is the one we're going to use mainly today. So if I go and do the same thing with a Q string, okay, I've got Q, class M, a parenthesis, and then I'm just going to close the string. Okay, oh, there we go. So as you can see, it has actually parsed what's inside the string and checked it and said, actually, that's not valid Scala syntax. So identifier expected, but end of file found. But if we go and complete the definition to make it valid, then it's fine. We got away with it. So definition.class equals class M. Okay. Now, how do we work out, though, how things are structured in Scala meta based on what we're inputting with these Q strings? You remember that we had x, y, z, and that produces a term.name. What you should do instead is you should do x, y, z, close the string, and then add just dot structure, okay? If you do that, you can find term.name. So it will actually tell you what it is that you have to do to create this structure. So we can do that for any level of complexity, really. If we go and do our literal number again, that's going to be lit.int. How about we do a Boolean? So true, that'll be lit.boolean. And you can kind of guess what it's going to look like for some of these simpler structures. So if we go and do a double, then it should parse as lit.double. Yep, there we go. And if we think of the one that we were doing, we had a function applied to some arguments. Let's do f applied to 1, 2, 3. Okay. And so that should result in term.apply, term.name, f, and then that applied to a list of lit.int, and lit.int. And what we could do is we could actually pick up this definition, paste it back in, and we'd get back the original code. Okay, so I think the only thing that we need to check to prepare ourselves to implement the solution is how a case class is implemented. So I've just done Q case class M, X is just a random integer that we're taking as a parameter. We've got dot structure. And if we run that, we've got this big, long, complicated definition. But I promise underneath it is basically just a case class. And we don't need to actually worry about the complexity of this because we're going to be doing this a different way. But just to look at it briefly, there's like a list of modifiers. So it's like case is a modifier. The name M is there as a piece of data. A couple of other fields, I don't know what they do. I'm sure we could find out if we looked up in the documentation. But the bit we're interested in today is term.param. So that's how we do this little parameter in here. Okay, so hopefully now we are armed with everything we need to know in order to go and implement this for real in our solution. So I'm going to go and close our console, and then I'm going to start. I'm going to do a little, so if you do this little tilde followed by run, that will get SVT to run your project every time some files are saved. So we're just starting off, we've got this project here. I've got importing Scala.meta to underscore as before. We've got object main extends app, so that means we're going to have a very, very simple app that you can just see how things are running. I've got an example field from the field definition we invented earlier, an example model, so we can play around with that, and we're just going to print something to console so we can just see it as changes are made. And just to remind you, here's the JSON from earlier. So imagine, in a real project, you would have some magical JSON serializers that would take this JSON in and present it to us as pure Scala. And the bit we're going to be implementing then is up here, object conversion. And that's got just 3 methods. And once we've completed those 3 methods, we are done. We will have a complete solution for this particular problem. So we've got convert model, which takes our original model, and that is going to return definition.class, which you might have seen before in the console. We've got convert field, which takes our field and returns the parameter that needs to go in the case class, term.param. And then finally, we've got convert type, which is going to return a Scalameta type. I think we can see that. Okay, so let's go and open up our console again. And I'm going to go and start writing some code, try and implement this solution. So we're going to start from the bottom. We're going to do convert type. I think I'm going to pick T string, and I'm going to say it is optional. Okay, and that runs, and straight away we've already got not implemented error, so that's fine. We'll go and see that because that's these 3 question marks. Now, because we did earlier, we used a sealed trait for our types, we can go and get the compiler, in fact, the IDE, to tell us exactly what we need to do to fulfill this match. So I'm going to go TPE match, and you'll see here VS Code has very helpfully put match exhaustive. I think that works just the same in IntelliJ if you're using that. So if we go and click on that, it will go and give us all the cases we need to cover. There's nothing else needs to be covered, so it's a total function on that. And we're going to, for T string, we're going to go type.name, and I think we're going to call it string because that is, funnily enough, the Scala string type. T number is going to be a number type. So I think what we'll do here is we'll pick int, but we could always change that. We could have long or whatever it is. Maybe the user has started using really big numbers and we need to handle those. That would be really simple. We'd just change that line. And the final case then is T boolean, which is of course type.name boolean. Okay, and straight away you can see that our little test down here, convert type, T string is optional, has started succeeding because we've got a result down here in our console. So I don't know if you can see that, we've got running demo.main string. Okay, so that works pretty well. The only problem is we are ignoring this is optional true case. Okay, so because I think if someone has said a field is optional, then we really want that to be option of string or option of int or boolean, whatever. Okay, so if you remember earlier that we have application of terms. Okay, so we have the idea that f applied to 1, so that is we're applying f to 1, okay? So if we apply the same logic for a type, then we can say that we are applying the type option to the argument string, okay? And you could do this for all sorts of other things. So you could say map of string and int, that would be applying the type map to the arguments string and int, okay? So all we need to do then is do type.apply, okay? And VS Code tells me here we need to put a type on the left-hand side and the arguments on the right-hand side, okay? So I'm going to go and call this base type in here. We need to put, I'm going to put type.name option. And then on the argument side, we're going to have a list. We're only going to put one result in there. That is going to be base type, okay? And then you can see down here, as I've rerun it, option of string. So it's now working correctly. But of course, what happens if we go and change this to is optional false? Yeah, option of string still, so nothing's changed. Just to show you there, we've got convert type is optional false, and that should be resulting in a string, but it's not. So we just need to have a little bit of logic. So the final piece of the puzzle here is if is optional. Okay, then I want to do this. Otherwise, you can just return the base type. And there we go. We can now see that that's working correctly. Okay, so if I go and change that to t-boolean, we should get a boolean. And if I say is optional true, then we should get option of boolean. Just to show you the definition very quickly, we've got a base type, we've matched on those, and then we're saying if it's optional, we need to apply it to the option type to get option of that type. Otherwise, we can just return our original base type. And you can imagine how we could extend this further. So we could say there could be something like if it's a list, just to write out the code. If it's a list, then you could do type.apply, and then on this side you could put type.name list, and that would go here. We'll leave that for now. The next thing we need to implement then is the convert field method. Okay, so that takes a field and returns a term.parameter. So I'm going to go and change my print statement down here. Convert field, okay, and I've got an example field that I've just put up here that's got a name of my field, a type of T number, and it's optional, okay. And straight away we've got a not implemented error. That's fine. Let's go and fix that. Okay, so term.param. I'm just going to see what VS Code says we need to include. So we've got mods, that's some modifiers. Then we've got a name. Then we've got a type of the, what type is this argument? And then finally a default. So just to break that down, if you imagine having a class and you might have private val x integer equals 34. Okay, so then we can kind of see where these are coming from. So we've got modifiers, we've got the actual name, and we've got a type, and then we've got a default. But we don't need modifiers and we don't need the default. So we're just going to go and say that we have no modifiers, empty list of modifiers. The name is going to come from field.name. Okay, the type, we don't yet have that, so I'm just going to put it there as a pretend variable, and there's no default, so we put a none there. And then we just need to get the type. So type equals convert type, field.type, and field dot is optional. So I hope you can see what we've done there. We've converted the type using this method, okay, which requires the arguments for the field's type and the field's optional flag. And then we're going to put that into our parameter, which has no modifiers. It's got a name of the parameter, a type, and no defaults, okay? And I've run that, and we should see now result. So we've got my field option int. We can just go and play around with that just to prove that it definitely works. So if we wanted to change this, we could say we could change it to Scalabase, and it would change the option of int, or if I wanted to make it a Boolean, Scalabase option Boolean. Okay, and the really great thing about using Scalameta is it handles all of the formatting. It makes sure this is always correct. So if I wanted to go and put an exclamation mark in the field, for example, that's pretty bad, but it does go and put it in backtick, so it's still valid Scala. I didn't have to worry about making any of those changes myself. Cool. So let's go and complete the solution with the final implementation, which is definition.class. Okay, so this is going to take a model and it's going to return definition.class. What we're going to do then, so I think if we just look again at the definition.class, it's quite long and annoying. What we're going to do is just make that a bit tidy. We're going to use Q strings from before. What we're going to have then is I want a case class. Okay, and that's going to have a name. I'm just going to have a variable in there I don't know about yet. It's going to have the argument list, and we're going to put fields in there. Okay, so that's obviously not valid because I haven't finished the definition. The name is going to be type.name, and the fields are going to be model.fields.map convert field. Okay, so what that means is, actually I'll write it out in full with a lambda. So if you have a lambda function which has got a field, and that is going to be mapping across all of the fields and just applying the function to each item in that list. Okay, and so that returns us a list of term.parameters to put in here. And the last thing I've done wrong is that we've got here a syntax error which says we found a list of parameters but we required just one parameter. Okay, and the problem here is that the Q string is assuming that I'm going to write out all of my parameters this way. Okay, but in reality I'm just going to provide it with a list, and to do that we just need a little sort of spread operator. So if we just put 2 dots, then that will indicate to the Q string that I want to take these lists and spread them across the arguments. Okay, and if we go and change our example to the final method, we're going to point it to example model, and we should find case class customer ID, first name, last name is active Boolean. So it's worked correctly. And just to go and prove that it's definitely working, let's go and put another field in. So likes Scalabase, Boolean is optional, false, because you've always got to tell us you like Scalabase, and it works. There we go. Great. And the final thing I just want to show you is this very helpful website that I've used before called Astexplorer.net. And it's really great. Even if you take away nothing else from the talk today, you can go on here and just play around and understand how Scala understands your source code. Okay, so you can put in some Scala on the side here, and then you can see how that is broken down by the parser in Scalameta, and how it's represented as a case class. So for example, I might have this restaurant here as a case class. That's got a name and a star rating, okay, and it's got constructor, it's got parameters, all these things, and you can go and look at them and just explore which part is represented by which part of the data. So that's really useful. And that really concludes my talk today. Thank you very much for listening. Thank you very much to the organisers of the talk for putting everything together. Thank you very much to my mentor for being really, really helpful and helping me get through this. All of the slides and code then will be available online at this GitHub talk link here after the talk. And I'll also be in the Discord if you have any questions, and be happy to help you out with that. So thank you.